All right, we're on to page 3 now of the test review, and the first question asks you to state the domain for each function. Now, the domain technically are all the values that x could equal for this function. And what I think is an easier question to answer is, well, what could x not equal? What would cause a problem? So for our first problem here, we can see that if this denominator equaled 0, that would be a problem. We can't divide by 0. So if x equaled 2, that would be a big problem, right? So our domain can be anything but 2. And the easiest way to say that is that x cannot equal 2. That's implying to everybody who sees that x can be anything else except for 2. So this would be our domain, x not equal to 2. Same thing over here. Instead of saying, well, what can x equal, let's ask the better question, what can x not equal? And so x, we just can't have this be anything negative, so it has to be positive or it has to be 0. And so if I think about that, that means 4 minus x has to be greater than or equal to 0. And if I add this x over, that means that x has to be less than or equal to 4. So it has to be from negative infinity to 4, including 4, but not that. So anything in there would work. If I put 3 in, if I put negative 2 in, anything I put in is going to give me a fine value there. But if I had anything bigger than 4, that's a problem. I put 10 in, that's going to cause a square root of a negative, and I can't do that. So again, when you're thinking about the domain, technically the domain is anything that, what are the values that it can equal, but I would ask that other question, what can it not equal? All right, now we're evaluating these. Without a calculator, again, we want to get real good at just understanding what these represent. So 2 pi over 3, if I do 180 divided by 3 is 60, times 2 is 120. If I make that graph, okay, I get this reference triangle here, and this is square root of 3, this is 1, this is 2. I went in the negative x direction, but not the negative y direction. Sine is opposite over hypotenuse, so opposite over hypotenuse gives me square root of 3 over 2. 180 divided by 6 would be 30, so we're just talking about a 30-degree triangle here. 1, 2, square root of 3. Everything's positive. Secant is the reciprocal of cosine, so instead of adjacent over hypotenuse, this is going to be hypotenuse over adjacent. Hypotenuse over adjacent gives us 2 over square root of 3. Right, moving on to here, this is 180 divided by 6 is 30, times 7 is 210. So if I draw in a 210, right, again, I get a 30-degree reference angle there. So 1, 2, square root of 3. I did go in the negative x and the negative y, so both of those are negative. Cosine is adjacent over hypotenuse, so I get a negative square root of 3 over 2 for that one. And then our last one here, cosine of pi, is right on the axis. So again, you got two options here. One option is just move one space over. Negative 1, 0 would be that point. First number is cosine, second number is sine. So cosine of pi would be negative 1. Your second option would be to think about the cosine graph. It goes from 0 to 2 pi. Pi right there in the middle is down here at negative 1. Whichever one seems right to you or more reasonable, that's the one you should do. Then we get these fractional exponents, and we want to be proficient at that. And it's negative, so right away we know this is going to be 1 over 16 to the 3/2 power. The half, it means square root. So we're going to take the square root of 16, which is 4, and then we're going to take 4 to the 3rd power. 4 times 4 times 4 gives us 64. Same thing over here. That negative means we'd flip it. Now it's already a fraction. It's already 1/3. So when you get that negative, what you can do is just flip it back over. Make it 3 to the positive 3rd, which is 27. So that's a nice quick way to do it. Otherwise, if you're doing like 1 over 1/3, then it gets real klutzy and you can make a mistake. When you see that fraction, you see a negative, it just can flip right away. Even if it wasn't a 1, you can flip it over and then cube it out. This one has the log of 2 base 8. So we want to know 8 to what power would get us to 2, right? So we know 2 to the 3rd power would get us 8, but we're going the other way. We want to know what we have to do. So it has to be some kind of root, right? And it's not the square root of 8, but if we did the cube root of 8, the cube root of 8 would get us down to 2. So that cube root as an exponent would be 1/3. 8 to the 1/3 power would get us 2 because the cube root of 8 is 2. All right? So you got to be a little careful. Like the mind sometimes could flip those numbers around, get you all caught up. Natural log of 1, natural log is a base e, so we're saying e to what power would give us 1? And so it doesn't matter what the base is, the only thing that will get you to 1 would be an exponent of 0. So that's our answer there. All right, then we're asked to solve these out from the interval 0 to 2 pi, so cosine x equals 0. Again, 0 is one of those that's going to land on one of the axis points, so you have two options there. You could make a graph of cosine and see that it's 0 at pi over 2 and at 3 pi over 2. Or you could use your unit circle, and you would see right there at pi over 2 and at 3 pi over 2, that's when cosine is 0. So one way or the other, you have to identify that this wouldn't be a reference triangle 1. This is going to be one of these axis points. Okay. Over here we have sine 3x. Again, 3x might be throwing some of you off. Don't worry about it right away. Just do regular sine of -1/2. Ask yourself, what quadrant is sine negative in? And that's quadrant 3 and quadrant 4. Then go ahead and make a reference triangle in that quadrant. Sine is opposite over hypotenuse, and then you should be able to fill it in. And from there, you should be able to come up with the reference angle. In this case, it's 30. Then you say, well, what would be the big angle that would have created this 30? So to get all the way over there, we would have had to gone 180 plus that 30, which would be 210 degrees, or 7 pi over 6. So we know that 7 pi over 6 is one of our possibilities. And then the good news is we don't have to recreate this. We know the reference angle is always 30 no matter where we're at for this. So that would have been 330, or 11 pi over 6. Okay, if you can do that, that's good. That's just your basic understanding of the sine function. What we're saying is that 3x, which is what we're taking the sine of, could be this one or it could be this one. So then if we divide by 3, we end up with 7 pi over 18 and 11 pi over 18, and that's what x could be then. Okay, because if we multiplied it by 3, it would multiply it back up to here, and we already said the sign of that is that. This is real good. There are maybe some other options that we should consider, and what we mean by that is, what if we were to continue to rotate around and come to a coterminal angle? What if we were to add 2 pi to this and move it all the way around? Now, because it has a denominator of 6, I'm not going to write it as 2 pi. I'm going to write it as 12 pi over 6. That's still 2 pi, but that'll let me add this quickly and make 19 pi over 6. That angle is in the same spot as this angle. It's just one time around first, and then it comes to that. Same thing here. If I add 12 pi over 6 to that, I get 23 pi over 6. And then if I divide those by 3, I end up with 19 pi over 18, and then 23 pi over 18. Okay. If I were to add 12 pi over 6 one more time to these, all right, I'd end up with 31 pi over 6 and 35 pi over 6. And then if I were to divide by 3, I would get 31 pi over 18 and 35 pi over 18. And that's going to be it. That's as close to 2 pi as we can get on there. Now, for your test, I don't think we're going to be this obnoxious about stretching it all the way out, but we probably will have you do at least 1 or 2 more until you meet the requirements there. All right? So that's page 3.